In this video, we want to consider a couple definite integrals. We recognize this is a definite integral because our integral sign has two limits of integration with it. So in this case, we're going to expect to get a number when we are done, unlike an indefinite integral. When these numbers are not present, we only expect to get a family of antiderivatives. The fundamental theorem of calculus tells us how to evaluate this expression. We simply find an antiderivative of our integrand, any one will do, evaluate that antiderivative at 3, and subtract evaluation at 1. So let's go ahead and take a look. To find the antiderivative of this term, just add 1 to the power, divide the coefficient -8 by the new power, we get -2. With this term we can do the same thing, add 1 to the power and divide the coefficient of 1 by that new power. We will evaluate this expression at 3 and subtract evaluation at 1. That's precisely what this bar notation at the end indicates. So we plug 3 into our antiderivative and subtract evaluation at 1. When you subtract the second evaluation, it's a good idea to use parentheses to preserve distribution of that -1. We can either compute this by hand or use a calculator, and we'll get a value of -156. We would have gotten the same value regardless of the constant that we attached to our antiderivative. Since 0 requires less calculation, we go ahead and use a constant of 0 when evaluating definite integrals. So let's look at a more complicated problem. Here's a definite integral where a substitution is required to figure out our antiderivatives. So let's see how substitution works with definite integrals. 6x squared looks like the derivative of x cubed plus 1. So we'll let u equal x cubed plus 1. And du is 3x squared dx. Now we want to set up our integral so that we see our du exactly. To see the 3x squared here, I'm simply going to rewrite my 6 as 2 times 3, and I can put that 2 outside the integral. So now we're going to take this expression and write it completely in terms of u. The integrand becomes the square root of u du. These limits of integration are in terms of x. I would like to rewrite those limits in terms of u for this integral. Well, this statement here, u equal to x cubed plus 1, gives us the relationship between x and u. So if I take 0 and put it in for x, then u will be 0 cubed plus 1, which is 1. And if I take 2 and put it in for x, then u will be 2 cubed plus 1, which is equal to 9. So because I've changed my limits of integration to terms of u, then I do not need to worry about my x's any longer. I simply calculate this definite integral. Since a root is involved, I want to think about the fractional exponent so that I can apply the reverse power rule. So this will be 2 raise the power on u by 1, so this will be u to the 3/2. Coefficient right here is 1, so this will be 1 over 3/2 or 2/3. And this is a definite integral. I want to evaluate at 9, subtract evaluation at 1. So this will be equal to 2 times our antiderivative here with 9 substituted in. Subtract evaluation at 1. And again, we perform this calculation by hand or with a calculator. And we get to a value of 104 over 3.